right, welcome to my presentation on sustainable methacrylates. So it's beyond bio-based. You will see that it's not just about bio-based monomers, but I will start with the bio-based monomers. So methacrylates offer all kinds of different functionalities. So if you use bio-based alcohols or bio-based diols, you can create many nice bio-based methacrylates. It's relatively easy because most of our methacrylates are produced in batch production processes. So coming from 100% fossil-based monomer, we end up with up to 85% bio-based monomer. So maybe you ask yourself now, why is it just 85%? Could be 100%. The reason is that, unfortunately, bio-MMA is still not readily available, at least not on a commercial scale. And also, what you could also use for at least reducing the carbon footprint would be recycled MMA. But this is also not yet commercially available, or not on a commercial scale. But that would be the big ambition for the future. So we'll closely track the availabilities here. Of course, bio-based does not necessarily mean that it's also sustainable. So that's why we also did life cycle analysis for our bio-based monomers to ensure that we really have a reduction of the carbon footprint when using them. Here you can see our product portfolio. So on the left-hand side, you can see our VISIOMER Terra products. So our bio-based products that are friendly labeled are called Terra, and it is our ambition to increase this portfolio of VISIOMER Terra products. You will also see that we have this the InsertCure certification, which certifies the biocarbon content using the radiocarbon method by the ASTM 6866 certification. These are just 3 monomers out of our portfolio you see here. That's long alkyl chain esters C13MA and C17.4MA, and the Terra Iboma. And we will also have this certification for our new products. Talking about the new products, we have 2 options basically. The first option is to do ready-to-make bio-based monomers. So this means that we have products in our portfolio, for example, these crosslinkers here, where you can use a bio-based diol, creating a new Terra product with, as you can see it here in the example, PEC-200 dimethacrylate, creating a Terra PEC-200 dimethacrylate with 50% biocarbon content. Then the new developments, and this is quite exciting, so they are based on readily available feedstock, but these create new structures that are not available in the fossil-based version, and these create new structures with bio-based carbon content of up to 84% here, having unique properties. I will show you in a minute. So then we are talking about this. So that would be the new developments here. First, coming to the ready-to-make bio-based solutions, I already mentioned that it was our ambition not only to provide bio-based monomers, but also to make sure that I have a reduced carbon footprint. And here you can see quite nicely that we have a correlation in biocarbon and global warming potential. For the first monomer, the PEC-200 dimethacrylate, when you use bio-based raw materials, you have 50% bio content and 21% reduction in carbon footprint. And for the 1,4-BDDMA, you have a bio content of 33% and 19% carbon footprint reduction. And you will also see that here for the EGDMA, which has a quite short spacer between the 2 methacrylate groups, you only have 20% bio content and 2% reduction in carbon footprint. So here, using something like a bio-MMA or also using recycled MMA, you would have a bigger lever on further decreasing the carbon footprint. So one product which we are commercializing is the VISIOMER Terra Pack 200 dimethacrylate, so really in its bio-based version. And here you can see a comparison. So it's, of course, for you as a customer, not only important to have a bio content in your monomer, but also to have the same performance and also the same quality. And that's what we show here. So this is a comparison of the polymerization time between the fossil PEG 200 and the bio-based PEG 200 dimethacrylate. And you will see that there is practically no difference. And we also have the same quality of our monomers, so we have the same specification. Now talking about the new developments. So these new developments are available as samples to customers, interested customers under CDA. That's why we have these rather spacey names here. So the first one is an oxidative crosslinker. That's not a crosslinker in the sense of a crosslinker, in the sense of a dimethacrylate. It's actually a monomethacrylate with side groups that can crosslink under the influence of oxygen. We have 84% bio content of this monomer. It's relatively soft. Then we have a rigid crosslinker that is maybe comparable a little bit to EGDMA if you compare it to a fossil-based version. And we have an alkyl methacrylate. We have one alkyl methacrylate 1 that is comparable to butyl methacrylate, and we have an alkyl methacrylate 2 that is comparable to ethyl hexyl methacrylate. Now let me show you some basic properties because we only have 10 minutes. So the oxidative crosslinker I was talking about is a monomethacrylate, so it's not a dimethacrylate. It's relatively hydrophobic. It can be used in emulsion polymerization, and you then can use the oxidative function for post-curing under the influence of oxygen. So you might as well use the secretives you know from alkyd chemistry to speed up the process. But you can also use this monomer and incorporate it, for example, into gel coat applications where it acts as an oxygen scavenger. And yeah, as mentioned, it has a bio content of 84%. The rigid crosslinker, it's a relatively hydrophilic crosslinker. Can be used in all kinds of applications, like reactive resin applications, but also as a co-monomer, for example, in core shell systems to cross-link the core with a shell. It is comparable to EGDMA, and it has also one unique property. That's a low polymerization shrinkage of only 8%, so that's really low for a methacrylate. Then we have the Terra alkyl methacrylate 1 that is comparable to butyl methacrylate. Can also be used in emulsion polymerization and reactive resin applications. It has a biocarbon content of 55% and is relatively hydrophobic, so we see an increase in water resistance when we incorporate it into polymers. And the same applies to the alkyl methacrylate 2. That has a little bit of a lower TG, is comparable to ethyl hexyl methacrylate, and can also be used in emulsion polymerizations. Now, I only talked about bio-based monomers, but my presentation is about beyond bio-based. That brings me to the next slide. So I mentioned a couple of examples. You have some levers of reducing your carbon footprint by using bio-based monomers. That's the ones you see here on the left-hand side. So that's really reducing your footprint with the different monomers we already have in our portfolio, but also using our new developments. But of course, you can also use sustainable processes to take care of your handprint. So one option is to do low temperature curing, so avoiding heating using energy. For example, we have VISIOMER 6976, which is a benzophenone methacrylate, where you can do post-curing under UV conditions, under daylight or UV light. Another option, talking about high solid coatings, where you want to use as little solvent as possible. so lowering the VOC. There you could use the VISIOMER Iboma, so that gives you actually two advantages. You have a bio-based monomer, and you have a monomer that reduces your solvent content because it reduces your resin viscosity in these high solid coatings very effectively. And then you're looking at sustainable processes. You might also want to have a look at the TOX profile. Then we're talking about sustainable end markets, where we will find also our methacrylates, for example, talking about styrene replacement for composites and lightweight construction, where you can use our 1,4-BDDMA as a substitute for the styrene, and also electromobility, where electrical isolation varnishes are used that use 1,4-BDDMA, PEC 200 dimethacrylate, or TRT-DMA as crosslinkers. So that's some options I want to show you today. If you're more interested in our products and would like to talk about sustainability or in general, please visit us at our booth in Hall 3C 426. Thank you.